so we want to discuss the polar form of a complex number. Now, recall that by standard notation, complex number z is denoted as x plus iy. Now, in other places, we can also denote this complex number z in pair of x over y, where x is the real part of the complex number and y is the imaginary part of the complex number. But take note, x and y are elements of real number. Now, we want to represent this complex number in polar form. Now, first, this is what we have. Now, what we need to do now is to find the value of x, the value of y.
Can you use it as polar representation of complex?
Yes, you can say polar representation of a complex number. Yes, you can have it that way. So what we want to do is we want to represent this coordinate of complex number in a polar form. Now, when we talk about polar form, so we're talking about the sin theta, the cos theta, having the angles between the complex number makes with the x-axis. So now, representing this in the graphical forms, now we have that this is the complex number z. Then we have from the origin O. So here is x, y. Then this is the y-axis, and this is the x-axis, and this line is perpendicular, so we have angle 90 here. So the angle that this makes with the x-axis is here, which is called theta. Now, OZ is the modulus of the complex number, which is represented as what? R, which has been done in the previous video. Now, we want to represent this complex x plus iy polar form. So what we need to find now is to find the value of x and the value of y. Now, recall that we have an acronym where we use defining the sine of an angle, the cosine of an angle, and the tangent of an angle, which we call it SOHCAHTOA. SOHCAHTOA means this is sine opposite over hypotenuse, this is cosine adjacent over hypotenuse, and this is tan opposite over what? Adjacent. Now, considering angle theta and the angle 90, which is the right angle triangle here, the x-axis is the adjacent, then the y-axis is the opposite, and OZ, which is the modulus of the complex number, is the hypotenuse. Now, considering this, so we need to find the value of x and the value of y. R is known already, which is the modulus of the complex number. So we now take note of x and r. So this is the adjacent, this is the hypotenuse. So what we need to use now is the cosine. So we have cos theta to be equal to, which is the adjacent over what? Hypotenuse. So which is equal to x over what? Now, cross multiplying, when we have this, so our intention is to find the value of x. So cross multiplying, we have that x is equal to what? R times cos what? Theta. So this is the value of x. So we'll go ahead now to find the value of our y. Now, considering angle theta, y and r, we see we have opposite over what? Hypotenuse, which is the sine. So we have sine theta to be equal to the opposite over what? Hypotenuse. So which is the same thing as the opposite there is y divided by what? R. So our intention is to find the value of y. So we cross multiply, and when we do that, our y is equal to r times what? Sine theta. So we're getting the value of x, we're getting the value of our y. Now, for some of us who do not know what r is, take note, r is the modulus of this complex number z equals to x plus iy. Now, you can check on our previous video to get on how to find the value of r. Now, this you can now substitute the value of y and x in our polar form. So when we do that, we have that z in polar form z will not be equal to what is our x, which is r what? Cos theta. Plus we have I. What is our y? R what? Sin theta. Now, so from here, our z is equal to r is common. So you factor r out. So we have r open bracket cos theta plus I sin what? Theta. So this is the polar representation of the complex number. So in order to find the polar representation of complex number, if you are given in standard form as z equals to x plus iy, then you need to find the modulus, which is this, and it is denoted as r, which is equal to the square root of x squared plus y. And you also need to find the value of theta. And theta is this angle here. And the theta, which is the angle there, is called the argument of a complex number. So in our next video, we'll find the argument of a complex number before taking examples on how to represent complex number in polar form. Thank you.